checkpoint 5. Okay, so we've got the sine of x over 1 plus the cosine of x plus 1 plus the cosine of x over the sine of x is equal to 2 times the cosecant of x. That's what we're trying to verify. Definitely want to work with that left side, don't we? So what are we going to do? Can't. That's only if I've got one thing on the bottom and two things on the top that I can pull apart like that. We're going to have to get a common denominator and actually push it together is what we're going to have to do. Okay, so what is my common denominator? Both of them multiplied together, right? So there's not anything in common with the two. So it means on the first one it needs an extra sine of x. And if I put it in the top, if I put it in the bottom, I've also got to put it in the top. And in the second term, it's already got the sine of x, so it needs the 1 plus the cosine of x. And not just in the top, not just in the bottom, but also in the top, right? Everybody see what I did? Good. And so what does this one become? Sine squared of x over this sine of x times 1 plus the cosine of x. And what does this become? What do you have to do with that one to find the top? I do have sine of x over 1 plus the cosine of x on the bottom. What else? I do have sine times 1 plus the cosine of x on the bottom. But what do I get in the top? What do I have to do? Full. I have to do the full thing. So I've got 1 times 1, which is 1. There's 1 cosine. There's a second cosine, so it's plus 2 times the cosine of x. And then cosine times the cosine plus the cosine squared of x. I have an extra eraser in my lap drawer here. If you'll just go over there and pull it out. Now what can I do? Lap drawer. The long, skinny one. I can add them together. So this becomes the sine squared of x plus 1 plus 2 times the cosine of x plus the cosine squared of x all over sine of x times 1 plus the cosine of x. Now, why did I want to do that? What benefit did I have to that? I got a sine squared of x and a cosine squared of x that are being added together, right? So they turn into, so it becomes 1 plus 1 plus 2 times the cosine of x over all of that. So 1 plus 1 is 2, right? So I got 2 plus 2 times cosine of x. Right? Now, what can I do with the 2's, though? Factor them out because there's 1 in each term, so I can go ahead and factor that. So I've got 2 times 1 plus the cosine of x over the sine of x times 1 plus the cosine of x. And now what can I do? So 1 plus cosine of x on the top and the bottom reduced down to 1s, and I am left with 2 over the sine of x. And what is 2 over the sine of x? 2 times the cosecant. Again, I didn't promise they were short, but they are doable. You just kind of got to keep plugging away at it. It is. Not going to lie about that. Okay? Y'all finished with that one? Check point 6. We have the cosine of x over 1 plus the sine of x is equal to 1 minus the sine of x over the cosine of x. Now, everything we've done so far, we can't do on this one, right? Everything's already in sines and cosines. It's already one fraction together. I can't pull it apart because I could pull this one apart. But I don't know how much help that's going to give me, right? It is equal. But what you have to do is you have to look for something that you can work with. And so what I want to try to do is I want to try to get this so I just have one thing in the denominator. And the way we do that, do you remember the thing called the complex conjugate, where we like had 2 plus 5i and its complex conjugate was 2 minus 5i? And the reason that we do that is because it gets rid of the inner and outer terms, because it's the difference of 2 squares when we multiply it together. Okay? We're going to have the same idea here. What we're going to do is we're going to take this one that's got the denominator that's got the 2 terms in it, and I'm going to multiply by the same thing, but I'm going to change the sign in the middle. I'm going to multiply this side on the top and the bottom by 1 minus the sine of x. So I have the cosine of x times 1 minus the sine of x over 1 plus the sine of x times 1 minus the sine of x. Now, I don't have to do anything to the other side because I multiplied by an appropriate 1. You're going to hear me say that a lot. Anything divided by itself is just 1, right? So I can use that idea and I can multiply the top and the bottom by anything I want without having to do anything to the other side. So I'm just going to leave that other side alone for right now. Remember we talked about that? Don't work on both sides at once. So if this is what I was talking about. If I multiply this bottom, look what happens. I've got 1 times 1, which is 1, right? I've got a positive and a negative sine of x times 1. Everybody see that? So the inner term is going to be gone. So it's going to be minus the sine squared of x. Everybody see why I use that one? You with me? And so I'm just going to leave that cosine of x over 1 minus the sine of x on top. Now what's beautiful about 1 minus the sine of x squared, sine squared of x? Turns into what? Cosine squared of x. So I've got the cosine of x times 1 minus the sine of x on top still, but on the bottom I can replace that with the cosine squared of x. Now what can I do? Well, it's already factored out. I got a cosine in the top and a cosine in the bottom. Can I not reduce that out? Right? Because cosine squared means I got cosine times cosine, right? So one of the cosines on the bottom and one on the top turn into 1s, and so I'm left with 1 minus the sine squared over the cosine of x. I mean 1 minus the sine of x over the cosine of x. Sorry. And they equal, and we're done. I've heard that before, that's why I do it. You want me to give it a mustache? All right. So if you see something like that where they've got it, one side's got that denominator where it's got two terms in it, you can multiply by and if it's a 1 plus the sine or a 1 plus the cosine or 1 minus the cosine or 1 minus the sine, you can get this nice way of multiplying by that conjugate kind of idea, and it'll let you change so there's just one thing in the bottom. Okay? So that's just a technique that you have to use sometimes. All right, the next one is checkpoint 7. So we have the secant of x plus the cosecant of negative x over the secant of x times the cosecant of x is equal to the sine of x minus the cosine of x. Okay? Ooh. Did you see that negative x in there? In an identity, it's very important that if you're going to try to make this side look like this side, see here we only got positive x's. We've got to take care of that first. We've got to make sure we have the same argument on these trig functions. So if one says 2x and the other one says 1x, you've got to always make them both be one or the other. Okay? That's part of this identity verification thing. So this one is one we might not remember, but that's the even and odd identities. And so if you'll look back at that first page that we talked about, it'll tell you what the cosecant of negative x is. It's either a positive cosecant of x or a negative cosecant of x. It's either even or odd. So is it minus the cosecant of x or is it plus the cosecant of x? Minus the cosecant of x, because it's what kind of function? It's an odd function. Okay? So good? Now what do I want to do? I know this has got two things in the bottom, but those two things are connected with a multiplication, not a plus or a minus sign. So I can separate them. So this becomes the secant of x over the secant of x times the cosecant of x minus the cosecant of x over the secant of x times the cosecant of x. And you just take the top and you put it over the entire bottom. Okay? We good? Now what happens? The secants cancel out in the first one to 1, so I get 1 over the cosecant of x minus. What happens in the next one? Cosecants reduce out to 1, so I get 1 over the secant of x. One over the cosecant is the sine of x, and 1 over the secant is the cosine of x.